Hi everyone, this is Kiranmay from H&S department. Today we are going to discuss about dielectrics in this session. Under this topic, we are going to have internal fields of a solid and Clausius-Musserti relation. This internal fields in solid is otherwise called as Lorentz field. Lorentz is the scientist who had derived an expression for internal fields in a dielectric solid. Coming to the internal fields in dielectric solid, to derive it, let us consider a solid that in which atoms are very closely packed to each other and interact considerably. When electric field is applied, the atoms are polarized. Each of the atom develops a dipole, and dipole moment will be produced. Therefore, electric field at any given atom is the sum of applied electric field plus the electric field due to surrounding dipoles. This results in local field, which is called as internal field or Lorentz field. To derive the Lorentz field, let us consider one solid dielectric material which is placed in between two parallel plate capacitors. Let there be an imaginary spherical cavity around an atom A inside the dielectric. Let us assume that the radius of the cavity is large compared to the radius of the atom, and the internal field at the atom site is given by four different fields. First field is applied field from positive plate to negative plate. Second field is induced field from positive surface to negative surface. Third field is field around the field due to the neighboring atoms. Fourth field is field on the surface of the cavity. So the internal field is summation of four different fields: applied field, induced field, field due to other neighboring atoms, and field on the surface of the cavity. Let us first of all calculate the field due to applied one. So E1 is the field intensity at A due to the charge density on the plates. That is, E1 is equal to d by epsilon naught, and we had derived one expression for the displacement vector in terms of polarization vector, that is d is equal to p plus epsilon naught E. Now substituting this relation in the expression, you'll get E1 is equal to p by epsilon naught plus E. This is the field due to applied one. E2 is the field due to induced field. That is, due to polarization, due to polarization, charges will get displaced onto the surface of the material. Hence, induced field will be produced, that is equal to E2 is equal to minus P by epsilon naught. This negative term represents that E2 is in reverse direction to the applied field. E3 is the field due to neighboring atoms. Since we had considered a cubic structure, due to symmetry, the field due to the neighboring atoms cancel each other. Hence, E3 is equal to 0. E4 is the field on the field on the surface of the cavity. So, for to deriving this, let us consider a cavity of radius r a cavity of radius r around an atom A. So if dA is let us calculate the small area over the surface of the cavity and integrate it for the complete sphere. So if dA is the surface area of the sphere of radius r lying between theta to theta plus d theta, then dA can be written as 2 into pi into pq into qr. So this PQ is nothing but R sine theta from right angle triangle, and QR is equal to R d theta from right angle triangle OQR. So substituting both of them will give you surface area, small surface area, 2 pi R square sine theta d theta. Substituting the same in the formula and finding the charge on the charge on the surface dA, this can be given as, see, polarization vector is nothing but charge per unit area, dq by dA. Horizontal component of polarization vector is p cos theta is equal to dq by dA. Then from that, dq is equal to p cos theta dA. So dq is equal to 2 cos theta. In place of dA, we are just replacing it with 2 pi r square sine theta d theta. So by using this, 2 sine theta d theta is formula for sine 2 theta. So pi square p pi r square sine 2 theta d theta. This is nothing but like p is equal to q by a, just replacements. What I had told you, q is equal to p into a, the horizontal component q is equal to p cos theta into a. Therefore, if you want to find out the dielectric field, the formula is dq by dq by epsilon naught a. Substituting the same formula, you'll get dq into 1 into cos theta by 4 pi epsilon naught r square. Here also we are just taking the horizontal component of the charge, p by 4 pi epsilon naught cos theta sine 2 theta d theta. This is the small electric field which is produced in a small area dA. Now if you want to find out the total cavity, E4 is equal to integral dE4. In place of dE4, just replace it with p by 4 pi epsilon 4 epsilon naught cos theta sine 2 theta d theta. Substituting the sine 2 theta is 2 cos theta sine theta, you'll get p by 2 epsilon naught cos square sine theta d theta. Again, d cos theta is nothing but minus sine theta. So sine theta d theta is nothing but d of minus cos theta. So in place of sine theta d theta, we are replacing it with d of minus cos theta. So we are having integration x square dx. So x square dx integration is x cube by 3. So in the same way, cos cube by 3, cos cube theta by 3. So limits are extending from 0 to pi. So this will become minus p by 6 epsilon naught cos cube 0 cos cube pi minus cos cube 0, that will give you minus 2. So minus of minus plus 2 will cancel 6 by 3. So p by 3 epsilon naught. This is the fourth field due to the charges on the cavity. Now summation of all the four fields will give you the total internal field, that is E1, E plus E2 plus E3 plus E4, where E1 is field due to the applied electric field, E2 is field induced field, E3 is field due to surface charges, sorry, E3 is the field due to neighboring charges, and E4 is the field due to surface charges on the cavity. Just substituting their values, E1 is E plus P by epsilon naught, E2 is minus P by epsilon naught, E3 is 0, E4 is P by 3 epsilon naught. Substituting them, cancel P by epsilon naught with positive and negative terms. So left over is EI is equal to E plus P by 3 epsilon naught. Hence, the local internal field or a Lorentz field or a local field can be given as E plus P by 3 epsilon naught. From this into Lorentz field, we can derive one more relation called as Clausius-Mossetti relation, in which we are going to take one cubic structure having n number of atoms. Then its polarization can be written as alpha into n into EI, where EI is internal field. Substituting its value and rearranging the terms, you'll get P into 1 minus alpha E n by 3 epsilon naught is equal to alpha E n E. We had just taken this P term from one side to another side. Now just getting this multiplication term onto the other side, it will become denominator. Now from we know that alpha epsilon naught E epsilon minus 1 is equal to P. Just substituting this one here will give you E will get cancelled out. So 1 minus alpha E n by 3 epsilon naught is equal to this one. So if you take this negative term to outside, that will become positive term. Again, you can take a common of alpha E n and 3 epsilon naught. The expression will change like this. So rearranging the terms will give you alpha E n by 3 epsilon naught is equal to epsilon r minus 1 by epsilon r plus 2. This is called Clausius-Mossetti relation. Thank you.